regarding potentiometer. So the aim of this experiment is calibration of a given ammeter by using a potentiometer. Apparatus required: potentiometer, is galvanometer, shunt resistance, Lackland cell, milliammeters, resistance box, battery, rheostats and connection wires. Theory: calibration of any instrument means standardization of the instrument with reference to another standard similar instruments or some calculated theoretical values. Let small I be the current flowing through the resistance R, then the potential difference at the end of the resistance R is equal to I into R. This potential difference, where I is the current in the milliammeter to be calibrated. This potential difference is balanced by the total length L of the potentiometer wire. Thus we can write I into R equals to L into E, where E is the potential difference per centimeter of the potentiometer wire, L is the total length of the potentiometer wire, that is equals to 1000 centimeter. If I is the current in the potentiometer wire and capital R is the total resistance of the potentiometer wire, then potential difference E equals to, we can write I into R whole divided by 1000. Now by substituting this value E in the equation 1, we can write I into R equals to LRI whole divided by 1000, or I equals to, we can write LRI whole divided by 1000 into R milliampere. This is the working formula. The procedure how to perform the experiment. So this is the circuit diagram for calibration of ammeter by using potentiometer. Now set up the electrical connections as follows. Connect the positive terminal of the cell to one terminal of the potentiometer. Potentiometer, it has two terminals, so one terminal we consider to the positive of the cell. Now negative of the cell connected to the one terminal of the rheostat. Other terminal of the rheostat we join it to the milliammeter. Then milliammeter to one terminal of E. Key to the other end of this potentiometer. This is the potentiometer circuit we had done, and this is the resistance circuit. So resistance, two terminals are there. So one terminal we choose and connect it to the positive of the power supply. Positive power supply, it is connected to the potentiometer, this terminal. So we join this resistance circuit to the positive of this one. Now same terminal we connect it to the rheostat. So when you join two wires, the wire should be like that. We have to tie this one and join it here. This part is the rheostat, one terminal we choose it here. Now rheostat other terminal, we connect it to the, here you see this millimeter we considered for calibration. So here two different terminals are there, 250 milliampere and 25 milliampere. We considered the lowest one, the 25 milliampere range we consider for calibration. So we connect this part to the 25 milliampere. Now the positive terminal of the millimeter, connected to the positive terminal of the cell. This is the Lachlan cell. So we consider positive one to the positive of millimeter. Now negative terminal we connect it to the key. Key it has two terminals, so it has two terminals, so we choose one terminal and connect it to the negative of the Lachlan cell. Now here you see in the resistance box one more terminal is left, so from here we are going to join to the galvanometer one terminal. From here two wires we are going to connect to the galvanometer 1 and the key 1. So here we are going to join two wires. One, we consider one terminal of the galvanometer. The other part we consider to the key. Now galvanometer one more terminal is left, so this one we connect it to the shunt resistance. This is the shunt resistance. Here small resistance it is connected in between these two terminals. And the other one, here see this gap it is connected with the low resistance, and this terminal we consider for jockey one. So we put the keys. Now let's complete our circuit connections. So this circuit, this is a potentiometer circuit. So in the potentiometer circuit you see we had done like that. The positive part of the cell we had connected to the potentiometer one terminal we had choose here, and negative part we connected to the millimeter negative, then positive to rheostat, then rheostat to key, and key to the other terminal of this potentiometer. And this is the resistance circuit. So resistance circuit you see two terminals are there. One terminal we connected to the cell through potentiometer, and the same terminal we connected to the rheostat, and rheostat it goes to the to be calibrated milliammeter. Here we consider the range 25 milliampere, so connected to the negative of this one, and positive part to the positive of this cell, latent cell. Negative part goes to the key terminal, and galvanometer one terminal we connected to the other terminal of this resistance box. Now galvanometer one part goes to the shunt resistance, and shunt resistance to the jyoti. In the potentiometer you see two terminals are there, so both the terminals wires are connected, means wires are started. But the terminal which one we consider to the positive power supply, the current starts flowing through this wire first. So we choose this one, this is the first wire, and this one, this is the last wire. So here altogether 10 numbers of wires are there, and each wire 100 cm long, so altogether 1000 cm length is there. Now, by adjusting the rheostat RH1 in the potentiometer circuit and putting a suitable resistance in the resistance circuit, this circuit in R, corresponding opposite deflections in the first and last wire are to be obtained. So, first wire and the last wire. So, opposite deflection we got it here. Now, current in the potentiometer circuit is kept constant by adjusting the rheostat RH1. So, here, this is the potentiometer circuit. So, here we require 70 milliampere. 70 milliampere. This we consider to be constant throughout the experiment, and here we had put it here 6 volt. Now, by putting a suitable resistance, say 500 ohm, I had taken it out from the resistance box, and by adjusting the rheostat, this is RH2, to get the desired current value here in the milliammeter, this is to be calibrated. So here we got it here, say 2.5 milliampere. 2.5 milliampere, this is the first observation. Now, corresponding null point is to be found out in respect of this current 2.5. So, let's start to check. First wire, second, third, fourth. So, here see, if these two wires, see, it shows the opposite deflection. See, this is a null point. Wire number this is 1, 2, 3, 4, fifth wire. Fifth wire we got it here 99 point. We got it here 99.4. So now we are going to entering the data here in the observation table. First one. So here to be calibrated in the millimeter, here we have set up this one 2.5. Resistance box, from the resistance box we have taken in out the resistance, this is 500 ohm. Standard millimeter constant current we have put it here 70, and null point we have obtained it here fifth wire 99.4. So our total reading here length of this potentiometer. Here you had got fifth wire, each wire 100 centimeters, so 4 numbers of wire you had crossed, so 499.4. So we write it here 499.4. Now this current is also obtained by calculation using the equation IRL whole divided by 1000 into R milliampere. By putting all the values in this equation, this is the working formula, and find the current value. This is the calculated current value here. So this calculated current value, we referred this one, this is I prime, and to be calibrated, this one is I. Now the last column is the correction part. Correction is I minus I prime. That is the difference between the to be calibrated ammeter reading and the calculated current value reading. So take the difference ammeter reading and the calculated current value reading. This is the correction value. This part also you have to found. Now in the calculated current value part, here you see, after doing the calculations, if you find that the calculated current value is less than the ammeter reading, then the correction is positive. I minus I prime becomes positive. And if you find that the calculated current value reading is greater than the ammeter reading, then the correction part is negative. Two graphs, I versus I prime and I versus I minus I prime, are to be plotted, and calibration can be analyzed. Now two graphs, I versus I prime and I versus I minus I prime, are to be plotted, and calibration can be made after analysis of these two graphs. So the first graph is drawn between the ammeter reading along x-axis, I along x-axis, and calculated current value reading I prime along y-axis. So the graph, it is a straight line passing through the origin. And the next one, this graph is to be drawn between ammeter reading I along x-axis and the correction part I minus I prime along y-axis. So the nature of the graph, it is like that. It is the positive and negative part, so it looks like in zigzag, so like that. So students, so far we have seen how to calibrate a given ammeter by using a potentiometer.